Well, welcome friends to my YouTube channel Sommo Physics. Sorry guys. In my last lecture, I have discussed about differential equation of the orbit and its few applications. Okay. Now in today's lecture, that is, we will discuss about artificial satellites. Artificial satellites. Okay, the first question that arises, what is artificial satellite? Okay, we know that Earth is rotating around the sun and the moon is rotating around the earth. Okay, so earth is rotating around the sun and moon is rotating around the earth. So moon is a natural satellite of earth. Natural satellite of earth. Since it is created by nature, it is a natural satellite of earth that we all know. Now artificial satellite, what is it? If an object is placed into the space with the help of a powerful rocket so that it begins circling around the earth, it is called artificial satellite of earth or any planet. Okay, so if we place an object into the space with the help of a strong or powerful rocket so that it begins circling around the earth, it is called artificial satellite of earth. Okay, so what is the definition of it? If an object is hurled into the space with the help of a powerful rocket so that it begins circling round the earth, circling round the earth, it is called artificial satellite of earth. Okay, so this is our definition. Okay, if an object is hurled into the space with the help of a powerful rocket so that it begins circling around the earth, it is called artificial satellite of earth. Okay, so this is the definition of artificial satellite. Okay, now the second question that arises, what are the basic differences? Okay, now we shall discuss the basic differences between natural and artificial satellites. The second question, what are the basic differences between natural and artificial satellites? Okay, the first point that is already mentioned in this, that natural satellites are created by nature and the artificial satellites are man-made. So this is the first basic difference. Okay, natural satellites are created by nature and artificial satellites are man or human made. Okay, so this is the first basic difference, that natural satellites are created by nature and artificial satellites are man made. Now the second point is that natural satellites are made up of natural elements like mineral, water, etc., and artificial satellites are made up of metal, or you can say electronic materials. Okay, so the natural satellites are made up of natural elements, that is mineral, water, etc. Natural elements, mineral, water, etc., whereas artificial satellites are made up of metals or electronic materials, or electronic materials. Okay, so this is the second basic differences, that since they are created by nature, they are made up of natural elements like mineral, water, but since the artificial satellites are man-made, it is made up of metals or electronic materials. Okay, this is the second basic difference. Okay, now third basic difference is that natural satellites will not be able to communicate with the instruments on earth, but artificial satellites can do it. Okay, natural satellites will not be able to establish natural satellites will not be able to establish radio contact with the instruments on earth, but artificial satellites can do it. Okay, this is another important difference. Natural satellites that are made up of by nature will not be able to establish radio contact with the instruments on earth, but artificial satellites can do so. Okay, fourth one is that natural satellites don't require any power. Natural satellites do not require power from outside, but artificial satellites require power from outside. Okay, so these are the basic differences between natural and artificial satellites. And remember one thing, that in this case, for our natural satellites, the power must be supplied by the panels of solar cell or small nuclear reactors. Okay, so power must be supplied by, say, small nuclear reactors, or you can say panels of solar cell, panels of solar cell. Okay, so these are the basic differences between natural and artificial satellites. Okay, so this is very important concept, you must have to know. Okay, now let us discuss the important issue. Our next task is to find out the orbital velocity and time period of an artificial satellite revolving around the Earth. Because it is circling around the Earth, we place these satellites in space in such a manner that they circle around the Earth. So, say this is the Earth center and this is the artificial satellite. Okay, so this is obviously the radius of Earth, and suppose the satellite is located at a height h from Earth's surface, that means this height is h. Okay, so if we call m mass of Earth, we call capital R be the radius of Earth. Okay, we call small m the mass of artificial satellite, mass of artificial satellite, and h is what? The artificial satellite is located at a height h from Earth's surface. Okay, height of the artificial satellite from Earth surface, height of the artificial satellite from Earth's surface. Okay, now if the satellite revolves around the Earth with an orbital velocity v, say v with the orbital velocity of the satellite. Okay, so these are the, at first we introduce the quantities. Okay, now at first we have to know there are two forces acting in that system. One is the gravitational force of attraction. Okay, so what will be the gravitational force of attraction? That is, sorry, the gravitational force of attraction, that is the force of attraction between the Earth and the satellite, that is g, mass of Earth, mass of satellite divided by their distance, h plus r. So that means r plus h whole square. So this is the force of attraction between the artificial satellite and the Earth. Now since the artificial satellite is rotating around the Earth, their motion is rotational, so there will be a centrifugal force, okay, which is a fictitious force that exists. Remember this, I will told it in class later, that for any rotational motion there exists a fictitious or pseudo force called centrifugal force. It only exists in rotational motion. So rotational motion, there exists a pseudo force or centrifugal force. Okay, now since the satellite is revolving around the Earth, there will be a centrifugal force. So what is this? We all know, mass of the satellite into its velocity square upon r plus h. So this is the centrifugal force due to the rotation of the satellite around the Earth, and the stability condition is that if these two forces are equal, then the system will be stable. So for stable system, these two forces must be equal. Okay, so for stability, above two forces are equal. Okay, So if we make equal these two forces, then what will be the result? mv square by r plus h, this equals to gmm by r plus h whole square. Cancels. So what will be my v square? That is gm by r plus h. And we all know the expression that acceleration due to gravity at Earth's surface can be written in this way. So from which gm we can write small g into r square by r plus h. So what will be my v? R into square root g by r plus h. Okay, so this is the orbital velocity of an artificial satellite revolving around the Earth. Okay, so this is the orbital velocity, and there you see that depends upon the radius of Earth. Okay, so this represents the orbital velocity of satellite. Okay, now our next task is to find out the time period of revolution. Okay, our next task is to find out the time period. Since we consider simple circular orbit, okay, we take here simple circular orbit. Okay, simple circular orbit. So it's okay. So what would be the time period of revolution? That is 2 pi r by v. And what is r? R means actually the distance between the center of Earth and the satellite. This. Okay. And v we found r root g by r plus h. So this is simply 2 pi by r plus h square root of r plus h by g. So this is simply 2 pi by r root over r plus h whole cube by g. Okay, 2 pi by r square root of r plus h whole cube divided by g. So this is the time period of revolution. Okay, so this is the time period of revolution. Okay, and we take r plus h as small r. We take this distance, that is this is radius of Earth and this is h, and we call the total distance r. So what we can write? We can write twice pi by r. This is simply r cube by g. And if you take square, so t square will be 4 pi square r square r cube by g, and these are constant quantities. Radius of Earth constant, acceleration due to gravity constant. So what we see? T square is proportional to r cube. Thus we see that an artificial satellite obey Kepler's third law. Okay, so what we conclude from this? What we conclude from this? We conclude that artificial satellite obey Kepler's third law. Okay, so in our today's lecture we have introduced the concept of artificial satellite. We discussed the basic differences between natural and artificial satellites, and we also find out the velocity as well as the time period of revolution of an artificial satellite. And there I saw that there we all see that artificial satellite obey Kepler's law. Now in my next lecture I shall going to discuss the special case when the artificial satellite is very close to Earth's surface. That we will do in our next class. So dear guys, kindly subscribe my channel to get latest videos on physics, which will be very useful for you. And this video link will be given in the description box. And if you have any query, then write it in comment section. Okay, thank you.